All right, welcome back. Today we're going to continue our discussion on exponents. Now we're talking about the product rule. We'll learn what that means in a second. Our goal is for students to be able to understand and use the properties of integer exponents to simplify exponential expressions. And it also wants students to be able to use properties of integer exponents to make equivalent expressions, meaning we're going to rewrite some exponential expressions by simplifying them. Let's go. What is a product? A product is two or more numbers multiplied together. Pardon the tapping. So here we have quite the process going on here. We have 3 squared times, when parentheses are next to each other, it means we're multiplying, 3 to the 4th power times 3 to the negative 3. Well, let's go back to what we know about integer exponents. Let's write this in expanded form. When in doubt, write it out. Expand it out. So 3 squared is just 3 times 3. Check. 3 to the 4th is going to be 3 times 3 times 3 times 3. Well, there's 4 of those. Check. 3 to the negative 3. Remember, we're going to switch this. So it's going to be times 1/3 times 1/3 times 1/3. We should have an understanding about multiplication, especially when we multiply fractions. We're going to have 3 times 3 times 3 times 3 times 3 times 3. That's a lot of 3's. Over 3 times 3 times 3. These are our, these are our 1/3, okay? That's why they're in the denominator now. And when we have fractions, if I have a common factor, I can cancel them out. So I have 3 divided by 3, that's just 1. I have another 3 divided by 3, that's also 1. And I have a last 3 divided by 3, that's also 1. So my final answer is 3 times 3 times 3. Let's write this in exponential form. It's neater. It's 3 to the 3rd power. Let's leave it like this. What do we wonder? What do we notice? What do we see is happening here? So I had a squared, I had to the 4th, and I had a negative 3. We're going to explore how we got these 3 exponents, and they all simplified down to a positive 3. So let's use our first sample problem to illustrate this point. When in doubt, we're going to write it out. 8 cubed is 8 times 8 times 8. So I have 8 cubed times 8 to the 7th. That's a lot of 8s. I should have picked a better problem. That's already 5. I'm going to lose count if I'm not careful. 2, 4, 6, 8. One too many. Told you I was going to lose count. So here's my 8 cubed, and here's my 8 to the 7th. How many 8s do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 8 multiplied together 10 times. Well, if I'm going to write this in exponential form, it's going to be 8 raised to the 10th power. What do you notice is happening there? How can I use these two numbers to get a 10? Basically, what math operation would have to go here to combine 3 and 7 somehow to get 10? Well, if you're screaming at me, addition, you're right. When we multiply 2 exponential expressions, and this is important, that have the same base, we are going to add their exponents together. Okay? So here we have a slightly more complicated sample problem, but the process remains the same. We're looking for similar bases. I have an x here and an x there. That means these 2 exponents I'm going to be adding together. Y is there's no other y in the other number for this product. And then we're going to talk about our coefficients here in a moment. So I'm going to write it in expanded form. I have 8 times x times 6 times x times x times x times y. Let's group our, oops, that's not what I meant to do. Let's group our similar, also again, not what I meant to do, our similar bases together, shall we? I'm going to color code them like I did earlier for consistency, okay? So I'm going to group my coefficients together. I have 8 times 6. Then I'm going to group my x's together. X times x times x times x times x, and then times y times y. 8 times 6 is 48. X times itself 5 times is x raised to the 5th power, and y times itself twice is just y squared. and we're done. This is as simple as this can get. Wrote it on an expanded form just to make sure we got everything right, and then we simplified it and condensed it. I'm going to do this one similarly, but I'm not going to write it out this time. I'm just going to quickly say I have two coefficients here. -4 times -2, that's +8, so we're done there. I have x squared. I'm going to figure this out eventually. I have x squared and x to the -4. Well, x squared times x to the -4 is going to give me that for my exponents, x to the 2 plus -4. And then my y is a y to the 1 and a y to the 0. If you see a variable and there's nothing here, it's implied that it's a 1. So that gives me y to the 1 plus 0. Let's simplify this. I have 8, and then 2 minus 4 is x to the -2 and y to the 1. We don't like to keep our negative exponents, so we're going to rewrite it, and we're going to flip x to the -2. Now it's in the denominator, and it's x squared. The negative is now gone, right? We took the reciprocal of x over 1, and then we squared it. The reciprocal of x over 1 is 1 over x. This becomes 8y times 1 over x squared. Let's do another one. Looks even more complicated, but if we keep our stuff organized, it will be easy to see. Got my coefficients here. So 3 times 4 is 12, times -2 is -24. Okay. Next I have my y's. I have y to the 5th, y to the 1, y cubed. Y to the 5th times y1. I'm going to add 5 plus 1 is 6 plus 3. So 5 plus 1 is 6 plus 3 is 9. So y to the 9th power. We're done. And then lastly, I have x squared. That's the only one. All right, x squared. We're done there. And then I have a new one. I have z to the 4th and z times z squared. So that's just going to add these exponents together. That will give me 4 plus 2, z to the 4 plus 2, which is 6. And we're done. Generally, the convention is to write our variables in alphabetical order. So try to stick with that, but it is multiplication. Order does not matter. Recap. So in general, what's happening? Well, earlier I wrote b as our base, and then we have n as our exponent. Let's say I multiply a similar, or the base is the same, but the exponent's different, right? So remember, as long as our bases are the same, this rule applies where I just add my exponents, b raised to the n plus m, where b is any number, and then n and m are, for now, integers. We will talk about what does it look like when they're not integers. For those of you who are my students, your assignment is going to be the product rule worksheet. I know. All right, thanks for tuning in. If you have any questions, you know how to get a hold of me. Take care.